Good morning, Geometry Semester 2 class. So this one is Unit 2 Pretest Analysis. So we'll take a look at that. And Unit 2 is all about conic sections. Again, this one is just give you the quick view about the whole chapter, the whole unit. So you guys do know what you're doing. So basically you can just go through this pretest and try to finish all of the assessments. According to the section, there are like a bunch of assessments that you need to pass through. And again, on Thursday, we're going to be doing the unit tests or the CST. So now let's take a look at that. So question number 1, identify and generalize the equation of a slope-intercept form of a line. So the previous unit, we talked about the slope-intercept form already. So the slope-intercept form, which is y equals mx plus b. So this one is quite obvious. And which form of a linear equation is defined by y equals mx plus b? That's a slope-intercept form. That's just another way to ask the questions. And which form of a linear equation is best used when given the steepness of a line along with the point where the line crosses the y-axis? It's also the slope-intercept form. Okay, so now question number 2. If y equals 2x minus 3 were changed to y equals 2x plus 5, how would the graph of the new functions compare to the original? So this one, I just want to find out about the transformation. So this one, if you see that the difference, it's about the y-intercept. So one is -3, the other one is 5. So that means it would be shifted up. It doesn't explain that exactly how many units is moving up, but it's just saying that it was being shifted up. And then for this one here, so it's a comparison of the slope. So one is a little bit more, it's a little bit higher, so 3, and the other one is 1, so it would be less steep for the other line right here. Again, it's all about the comparison. So here's another one about the slope, so it would be steeper because one is 2, the other one, the new line here is 5. And they both share with the exact same y-intercept. Okay, so for question number 3, which of the following linear equation has the steepness slope? Steepness slope, that means the slope got to be a higher number, so the value of m got to be higher. So according to the selection here, so a would be the highest, so that would be y equals ax plus 1. Okay, so here's another one, quite similar, so we can skip that. So you just need to pick up the one with the higher number. And this one has the steepness slope. It's also, either you want to find out the highest number or you want to find out the smallest number here. So this one is negative with the fraction, so this one would be -7. So now finally we get into the conic sections, identifying the vertex, nap, and edge of the right circular cone. So what's the name of the half of a right circular cone? So this one is called the nap. Okay, so the nap. And what's the name of the point where the two nap of a right circular cone meet, as shown below? So anytime that they meet, so see that the little point here, so this one is called the vertex. And what's the name of the sides of two nap of a right circular cone, as shown below? So you see that the red line here, so this one is actually called the edge. And which one of the following is best definition of a conic sections? So definition of a conic section, so this one is describing a curve resulting from the intersections of a right circular cone in a plane. Again, it's all about a curve. So for the higher math class, it's called the curvature. So this one is just about the curve resulting from intersections of a right circular cones in a plane. So a conic section is formed by the intersection of two geometric objects, the plane and the right circular cone. So that's just another way to ask the question, which of the following is formed by the intersection of right circular cone and a plane? So it's a conic section. So now this one is about the different kind of perspective. So identifying the three shapes of, that are formed when a plane and a right circular cone intersect through the vertex. So let's say that we do have a projector projecting on the nap, and then we do have like a different kind of view to find out the element. So a right circular cone is intersected by a plane that passes through the cone's vertex and is perpendicular to its base. as in the picture below. So what is produced from the intersections? So obviously this one is a pair of intersecting line here. It's a pair of intersecting line. Okay. A right circular cone is intersected by a plane that passes through the cone. So here's the view. So what is produced from the intersections? So this one, it's just producing the point. And here's another one. So according to the view here, so what is produced from the intersections? So this one is just a line. And here's another one for the productions. So this one, it's actually showing that it's an ellipse. So the cross-section area, if the nab is being slanted, and there's a camera or the light which is perpendicular straight through the slanted nab. So the cross-section area here, it's called the ellipse. Ellipse, which is the two-dimensional oval, is showing the curvature. And here's another one. So what happens if the cone it's perpendicular straight and the light is going through perpendicular to the nab? So the cross-section area here, it's called a circle. Because that is showing, well, the cone is showing that bunch of this right here. So the cross-section, the horizontal cross-section here, it's a circle. So here's another one. So the plane passed through only one nab of a right circular cone, and it's parallel to its base. Again, the light here, the light beam, as you can see, that is actually parallel to the base of the cone, of the right cone. And what conic section is produced when both nab of a right circular cone are intersected by a plane, and that does not pass through the vertex of the cone? So this one is a little bit kind of slanted, going through this way, slanted, if that's being cut. So this one will be considered a hyperbola. We'll talk about the shape of the hyperbola in a minute. So hyperbola is going to be like a symmetrical parabola. And the picture below illustrates a special type of a conic sections called a hyperbola. So here's the examples. So if the light beam just cut up the nap like this, so the cross-section area, so this one it's going to be showing that the symmetrical parabola. And the symmetrical parabola is called the hyperbola. And we'll talk about that in just a sec. So this one, the plane does not pass through the vertex. The vertex is here. And intersect both nab of a right circular cone. So here's the one, here's another view. So what happens if the light beam just cut off part of the nab, either the upper nab or the lower nab? So the cross section here, it's going to form a parabola. Parabola is a U-shaped object. And for question number 9, so which term is defined as the distance from the center of a circle to any points on a circle? So you see that the distance from the center of a circle to the point on a circle, it's called a radius. Okay, so that's something I'm going to show you in a minute. Okay, so let me just open up the new slide here. So showing that circle. Okay, let me just turn on the Active Inspire. Okay, don't worry about this part. Okay, so now, since we do have a circle, so let me just show you that right here real quick. Okay, looks like I need to use a compass. There's no shape that I can apply from here. Okay, anyway, so I'll just do that. Not even a compass showing here. Okay, so let's say that we do have a circle. Okay, maybe I can just do this. Okay, so let me just copy this one. Okay, so we do have a circle. So the center of a circle, that means it's the midpoint. It's the point right here at the center of the circle. So to any point of the circle, so there's infinitely many points on the circle here. So let's say that you want to construct a segment, a line segment from the center of the circle to any point on the circle. So, and this one is called the radius. So what I just construct here, so this one is just the radius of that circle. Okay, so now let's look at that, the next one. And which of the following geometric term correctly named the point inside the circle? So obviously this one is the center, it's not the vertex. So vertex, you can say that's either the highest or the lowest point on the geometric figure. So center, so this one is the point right inside the circle. So again, here's another situation for that radius. So construct that the distance right from the center all the way to the point on the circle. So it's a radius. And now what about, let's say that we do have an oval. So this one is called an ellipse. So let's say that you try to find out the longest distance from one endpoint to another endpoint of an ellipse. This one is called the major axis. Okay, so the major axis. And what about the shortest distance from one endpoint to another endpoint of the ellipse? So this one is called the minor axis. And then let's say that we do have two eyes. Okay, so eyes on the oval. So it looks like a cartoon figure. So this one is called the foci, or the focus. Okay, so foci, that would be the plural, and focus, that's the singular. And now which conic section is defined by the set of points in a plane which that the sum of the distance of two fixed points equal a certain constant. So let's say that you connect the one point on the ellipse, and then we just want to link to the focus, the foci. One is y, the other one is x. So what kind of figure this one is? Obviously it's an ellipse. And which one of the following statements best describe the relationship between any point of ellipse and each of the two foci? Again, the sum of the distance to each focus equal to a certain constant. So that's what is being described from the previous problem here. And then the next one, which two fixed points define the shape of ellipse? The foci. Okay, so two foci. We don't say focuses, foci. Okay. And now here's what I'm talking about for the hyperbola. You see that the blue curve right here? So this one, you can say that's a symmetrical parabola without the red line showing the slant asymptotes. So don't worry about that. The slant asymptote shows the boundary. And the blue curves here, so that shows the hyperbola. And in the graph below, the hyperbola get close to the red line, but never touch them. And which of the following terms best describe each of the red line asymptotes? Again, asymptote, it shows that the boundary of the symmetrical parabola. And what's the name of the green segment in the hyperbola below? So this one is called the transverse axis. Transverse axis. So let's say that I connect the vertices from one endpoint to another endpoint. Now, I'm going to be careful with the point bounded by the hyperbola. So this 2 points, they're called the foci for the hyperbola. And the green line right here, the green line segment. So once you see that, it's being connected with the endpoint to another endpoint. So this one is called the transverse axis. So what's the name of each of the two blue points? So again, focus or foci. And what's the conic sections? Well, conic section is defined by all points in the plane where the difference between the length of the segment x and y remains constant. Well, obviously this one's the figure of hyperbola. And which two fixed points define the shape of hyperbola? The foci. And which of the following terms best describe the set of all points in the plane for which the difference between the distance of a given point to two fixed foci equal a certain constant? So it's obviously it's a hyperbola. So now finally we get into the parabola. So parabola, the special feature about this, so this one not only has the vertex, the focus, but also the green line here, it's called a directrix. Okay, so what's the name of the green line? So this one is called a directrix. And what's the name of the red dot located on the curve of the parabola below? So it's a vertex. And what's the name of the blue dot? So that one is a focus. So you might be wondering, so for the hyperbola, parabola, so both of them, they both involve with the focus or the foci. And also same thing happening with the ellipse. But what about the circle? There's no focus, okay? It's just the center and the radius. So the next one, what's the distance between a given point on the parabola and the parabola focus? If the distance between the same given point and the parabola's directrix is 5 units. Okay, so what's the distance between the given point of the parabola and the parabola's focus? So it's also what? It's 5 units. And what's the distance between the given point of the parabola and the parabola's directrix? If the distance between the same given point and the parabola focus is 8 units. So this one you actually have to, okay, let me just demonstrate one example. So using this slide right here, so let me just make a parabola. Okay, so let me start it off with the xy coordinate. So let's say that we do have an xy coordinate. Okay, this one doesn't look that good. Okay, 2. Oops. Okay, so let me just resketch that on the next page right here. So let's say we do have one line here, or line segment. So that's just the x-axis, y-axis. And now I'm going to be making the parabola. So it's right here. So let's say we do have a parabola, just like a normal parabola. So here's the focus, here's the vertex, and here's the directrix. So as you may be wondering, so the distance here, they're equidistant, okay? So the distance from the vertex to the focus, and which is the same as the distance from the vertex perpendicular to the directrix. Okay, so, and that's why one of those is the same distance, the other one is what? It's twice as much as the other one. Okay, so now let's go back here. So this one, as you may notice, so half of the distance, which is what? 8 units, while the other half is also what? 8 units. And which of the following statement best describe the transverse axis of the hyperbola? So this one equals the difference between the distance from any point on the hyperbola to each focus. Okay, so any point that you have on the directrix, I mean on the transverse axis, so it's the same kind of distance to the focus. And which of the following statement best describe the location of the vertex of the parabola? So this one is always located halfway between the parabola focus and the directrix. And which of the following statement best describe the radius of a circle? Its length is the same of any points on a given circle. So if you just go back to the diagram for the previous page right here, so it's the same distance. It doesn't matter where you put a radius, over here, so it's the exact same distance. So let me just set up another radius right here. So it's the same radius as this one. So let me just make another one. So same radius. So this one is kind of like a Mercedes-Benz logo. Okay, so now let's see what else that we got for the rest of this. So question number 17. So the circle below is centered at the origin and has a radius of 4. So what is the equation? Okay, so let me just copy and paste this one here. Okay, transfer this one to the new slide. So now here's the diagram. So we need to set up the equation of the circles. So one thing that you probably don't know, it's about the equation of a circle. So the equation of a circle, it's quantity of x minus h square plus y minus k quantity square. So that equals r square. So where h and k is the center of the circle and r is the radius. Okay, so now what we got here, so h and k, so this will be 0, 0, because that we start at the center at the origin. Radius is 4. So with all the information that we have, so we can just plug in a number. So x minus 0, quantity square, plus y minus 0, quantity square. So that equals 4 square. And then from here, we can simplify it a little bit. So x quantity square plus y quantity square, so that equals 16. Okay, so what we got there, so this one would be answer B. And then the next one is quite similar. So x squared plus y squared, so that would be 7 squared. So 7 squared is 49. So the correct solution is D. And this one too, x squared plus y squared equals 25. So answer A. Okay, so the rest of this is quite similar. So we can skip that. So that one is about finding the equation of a circle. So now what about for question number 19? What's the radius of the circle with the equation x squared plus y squared equals 16? Now got to be careful with that. 16 is not the radius. 16 is considered r squared. So what you need to do, you want to take the square root of that constant number. So we end up with 4. And a lot of people might be wondering what happened. Can that be negative? Well, the length for the radius cannot be negative. It's always being positive. And then 19b, it's quite similar. Take the square root of the constant, so you'll get the radius. Okay, so that we can skip through it. So now, which of the following equations, which one of the following points represents the center of the circle whose equation is quantity of x minus 3 squared plus y minus 2 quantity squared equals 16? Again, the value of h and k. So this one we consider 3 and 2. The minus, we don't count the minus. Because minus, that's part of the structure of the equation of a circle. So the center of the radius, the center of the circle, which is considered 3, 2. Again, the minus sign, we don't count it. So the center of the circle here would be 5, 4. And this one would be 3, 6. Okay, so now here's the one with the center. So the center is something other than 0, 0. So what you need to do, you just want to find the radius. Well, it's given already. And also the center, so it's 2, 3. Again, we just need to put it into the equation of a circle. So it's x minus 2 quantity square, and then plus y minus 3 quantity square. So that equals 4 square. So 4 square, which will give you 16. So the answer is C. So here's another one. So started with the center. So the center is 10, 4. So this will be written as quantity of x minus 10 square plus quantity of y minus 4 square. So that equals 4 square. 4 square, which is what? 16. And here's another one. So just plug in a number to the equation of a circle and then just find out the matching equation. Okay, so here's another one. So got to be careful with the negative. So x minus -1, that would give you x plus 1 quantity square. And then the other one, that's y minus 1 quantity square. So that equals 3 square. 3 square would be 9. So the answer is C. So again, it's all about using the formula for the equation of a circle, but you got to be careful with the little sign change. Negative times negative turns out to be positive. Okay, so let's skip through all this. So which of the following is the results of shifting a circle with equations x minus 2 quantity square plus y minus 3 quantity square equals 25 up to units? So if that's up and down, so that means there's no change for the x coordinate. The only change is just the y coordinate. So the answer would be B. The y coordinate of the center of the circle increases by 2. Excuse me. And here's another one, up 4 units, so that means the y-coordinate of the center of the circle increases by 4. And what about down 2 units? So that means decreases by 2. And this one, the circle is moving to the left or to the right. So that means there's no change for the y value. It's only the change for the x value. So the x-coordinate of the center of the circle increases by 2. Because that's moving to the right, which is going to the positive direction. If that's shifted to the left, so that means it's considered decreases. So here's the next one. So write 4 units. So again, there's no change for the y value. It's just a change for the x-coordinate. So the x-coordinate of the center of the circle increases by 4. To the left, so that means decreases by 2. And the equation of y equals ax squared describe the parabola. If the value of a is positive, so which way does that parabola open? So a is being positive, that means the parabola is facing upward, because this one is just like a general parabola equation. If a is negative, that means the parabola is facing downward. Okay, so like this one here, so -3, so the value of a is negative, so that means the parabola is facing down. Okay, so this one also open up, so that means, well, if the value of a is negative, so that means the parabola is open downward. What about the sideways parabola? So the sideways parabola is the same kind of idea. So if a is being positive, so that means the parabola is facing to the right, because that on the number line, the right-hand side is all being positive. If a is being negative, that means the sideways parabola is facing to the left. So if a is being positive for the sideways parabola, so this one obviously is facing to the right. So it's kind of like a common sense. And now this one, and now the sideways parabola. So a is being negative, so that's why it's facing to the left. Positive, facing to the right. Okay, so now the next one I would like to talk about is the way to set up the equation of a parabola. Okay, so number 27, so let me just highlight this one. Once again, I'm going to copy and paste so I can do it on the other slide here. So for this one, so what you need to do, you need to apply some kind of algebraic approach. So what's the vertex form of the equation of a parabola is, okay, I cannot copy down the equation here, so let's see. Copy image. Paste. So here's the equation of the parabola. So as you can see that it's a regular parabola, it's either facing up or down, because that you started with y equal first. Well, if you started with x equals first, that means a sideways parabola. And also you see that x is being square. So this one is just the structure of the parabola. I mean, I can go into a little bit more in depth for this. So let's start with the structure. So if that's just like a normal up and down parabola, so usually the general form, it's given like this. So it's y equals a times the quantity of x minus h squared plus k. So where h and k is the vertex. So it's the vertex of the parabola. So earlier, what I show you here, it's about the parabola. So let's say we do have the x-axis, the y-axis. So the parabola is going this way. So that means the vertex is just the lowest position here. Again, if a is being positive, that means the parabola is facing upward. If a is being negative, so that means the parabola is facing downward. Okay, so what we found here is the vertex, the value of a. But now the question is asking about the way to expand it. So another way to expand it, so we can just multiply that x minus 4 out. So back to algebra 1, this one can be written as x minus 4 times x minus 4. So which means that I can FOIL. So FOIL, that means you can do this first, outside, inside, and then last. So x times x, so the first term would be considered x squared. x times negative 4x. So that's the outside term. And then the inside term, it's also considered negative 4x, negative 4 times x. And then the last term would be negative 4 times negative 4, which is 16. So once you combine the like terms, again, FOIL, first, outside, inside, last. And then what you can do for the next step here, combine the middle terms together. So x squared minus ax, so plus 16. So basically this one can be written as 1/2 times x squared minus ax plus 16. And then don't forget about that constant 13, it's outside the parentheses. And then the rest of this we can just distribute, so 1/2 times x squared, 1/2 x squared, half of negative ax, negative 4x. Half of 16, which is 8. And don't forget about the constant once again. So the final step, what we can do here, we can combine the like terms. So a and 13, which is considered 21. So that would be the final form. It's called the standard form of the equation of a parabola. So the standard form in general, it's considered ax squared plus bx plus c. So back to Algebra 1, you guys learned about the quadratic formula and the way to apply it to find the zeros. So we need to find the value of a, b, and c. And that's what we just found out exactly. Okay, so now let's go back to the slide. So this one is choice C, so the one after we expand it. So here's another one you probably want to try. So this one, well, the thing is that this one is asking about the vertex form. So the vertex form, that means we need to go backward. We need to find out from the standard form back to the vertex form. So what you need to do with this type of problem, and it looks like you guys need to complete the square for this. Okay, so once again, I'll open up a new slide. Okay, let's see, it's going to take a little bit of time here. Copy and paste. I had to do it twice. One is for the instruction, the other one is for the image. So again, the one that's given here, so this one is just the standard form. The standard form of a parabola. So we got y equals 1/2 x squared minus 4x plus 21. So for those who might be wondering, how do I go from the standard form to the vertex form? So the way to do it, so we need to complete the square for this kind of situation. And I'm sure some people probably have learned about completing the square in Algebra 1. So what we need to do with this equation, we need to isolate the x terms from the constant term first. So I just want to separate the constant terms along with the x terms, x squared and the x term. And then from the x group term here, so what we can do, we can take out the greatest common factors, so which we can take out 1/2. So now we're left with x squared minus ax, because we're going backwards, so we're taking out the small number, so that means this one we need to enlarge that twice. And then plus a blank, so the blank, that's the number we need to figure it out so we can complete the square for this whole quantity. And then plus 21, so that's just a constant term, so we just want to isolate it. So what I did here, I just take out the greatest common factor among the x group. So now 1/2, we don't do anything about it because that's the value of a, so bring it down. And now, in order to figure out the number here, so we need to apply the completing square formula. So that one will be considered b over 2 quantity square. So the value of b obviously is what? -8. And then divided by 2 quantity square. So we do have -a over 2, then that would be -4 quantity square. And that's 16. So now we're adding 16 here. So maybe I should use a different color for this because that's a brand new number I'm adding on. So this one, let's use blue. So whatever the number that you add here, got to be careful with the quantity. So the number you're actually adding, it's not just 16. It's 1/2 times that constant. So that's the actual quantity. You're adding it for the equation. So we're adding a here. So that means outside the parentheses, we need to try to even things out. So that's why we need to subtract that constant. So 1/2 times 16, that's 8. So we're actually adding 8. So that means, in other words, so we need to subtract 8. The reason why that we have to do this because we need to balance the equation. So once you're being able to balance the equation, so that means you only change the expression a little bit, but you don't change the whole quantity. And now for the rest of the step here, you just want to factor it. So back to Algebra 1, the way to factor, you can do it either mentally or you can just do it with the square method or the smiley face method. So what we got here, it's x minus 4 quantity square. So again, the way to factor, so xx, so 16 is just like -4, -4. So we got 1/2 times the quantity of x minus 4 squared, and then 21 minus 8, so that would give you 13. So finally, the equation would be considered the vertex form. So y equals 1/2 times the quantity of x minus 4 squared plus 13. Compare and contrast. So y equals a times x minus h quantity squared plus k. So now going back to that page here, so what we found here, it's D. So now here's another one you guys can try. So again, we need to convert the standard form to the vertex form. Okay, so instead of copying down the instructions, so I just want to copy the image. So let's just do a quick transferring. Okay, copy and paste. So now here's another one. So just want to show you how I convert it. So you started off with y equals -2x squared minus ax minus 13. So once again, the first thing that you want to do, you want to isolate the constant term, and then you want to group all those x terms. So the x squared term, the x term, so separate them with the parentheses. And now you want to take out the greatest common factor, which is -2, just the greatest common factor, the coefficient, not the variable. And now what we left here is just x squared plus 4x. And now you want to put in the blank because you want to figure out the number for completing the square. So now the way to complete the square, again, identifying the value of b, so it's b over 2 quantity squared. So we got 4 over 2 quantity squared, which is 2 squared. So then that means we're adding 4 here. Got to be careful, the number that we're adding, it's not just 4, it's actually the product of the greatest common factor and the number we just add on here. So the number we're actually adding, it's -8, because -2 times 4 is -8. So that means outside we need to even out the number, so we need to add 8. So now what we found, the rest of the step here, so we're pretty much almost done with the transferring and also the conversion. So this one is -2 times the quantity of x plus 2 squared. Again, this one, the trinomial, is factorable. Alongside with that, it's xx. I try to show the word. So 2 and 2, so it's a perfect square trinomial. Minus 13 plus 8, then that'll be considered -5. So finally, the equation would be considered y equals -2 times the quantity of x plus 2 squared minus 5. So now going back to that page, so the answer would be B. So 28 is quite similar, so that's a sideways parabola. Maybe we should try one of those. So this one, so which of the following could be the equation of a parabola that opens to the left with the vertex 5, -12. So now, this one it's a little bit different compared to what I just showed you, because the one that I showed you for the previous one, so those are just a regular up and down parabola. But now, if that's a sideways parabola, the structure might be slightly a little bit different. So now, let's take a look at that. Okay, again, I just want to copy and paste. New slide. Okay, so just bear with me here. Paste. Okay, so now, the structure for the sideways parabola, it's actually written like this. So it's considered x minus h, so that equals a times the quantity of y minus k squared. So now, for those you might be wondering, so this one, again, h comma k is still considered the vertex. So the sideway parabola, it's a little bit different compared to the normal up and down parabola. So let's say we have a parabola facing to the right. So h comma k would be the vertex. You can say the endpoint. So again, this one is showing kind of like a transformations graph. So once you get into Algebra 2 next year, you'll see that transformation with that h comma k. But I just want to stick with the basic form. So what we got here is the vertex is 5, comma negative 12. So that means the value of h is 5, the value of k, it's negative 12. So by plugging a number, so what we can find out here is that x minus negative 12. This one is showing that a, it's open to the left. If a is open to the left, that means, well, the value of a would be considered negative. So let's say that we put in the negative number. Okay, so negative number. Let's just put in a first. Okay, so y minus, I think I did something wrong here. So the value of h is supposed to be 5. So it's h positive 5. So it's supposed to be written as x minus 5. Okay, so I'll fix this. So that equals a times the quantity of y minus k. So k is negative 12. Quantity square. So like that. So eventually it's considered x minus 5 equals a times the quantity of y plus 12 square. Again, a, it's negative. The reason why it's negative because that the key word is saying that the parabola is facing to the left. So we just want to notify that a, it's less than 0 because that the parabola is facing to the left. So try to construct the parabola. So we got 5 comma negative 12. 2, 3, 4, 5. So let's say negative 12 is all the way down here. That means the parabola is going this way. So now going back to the solution, what we found here. So the answer would be A. As you can see that the value of A is being negative. So instead of setting up the equation, you can just tell that what the value of A is. So if A is being negative, so that means the sideway parabola is facing to the left. If the value of A is positive, so that means the parabola, the sideway parabola, is facing to the right. Okay, so here's another one. So open to the left, so that means the value of A got to be negative. And the rest of those sideway parabola, well, they're not even sideway. This one is just like a regular parabola, up and down. So the only choice that we have is C. Okay, so this one's open down, so it's a regular parabola facing downward, so that means A got to be negative. So got to be careful with the selections. So if that's just a regular parabola, up and down, so that means got to be y equals something. If that's a sideway parabola, so that means x equals something. And number 29, so if the vertex of the parabola is negative 4, 6, and now the points on the curve is negative 3, 14, what is the coefficient of the square expression in the parabola equation? So basically this one you want to find out exactly what A is. Okay, so now let's do that. So a lot of people kind of confused about which one to pick. So now this one you want to do some more analysis. Okay, so let me just create a new slide here. So one thing that we notice, we do have h comma k, which is negative 4 and 6. So the points on the curve is negative 3, 14. So let's say this one is x, this one's y. And this one was the coefficient of the square expression in the parabola equation. Now, the problem is that it doesn't tell you exactly what kind of parabola this is. Okay? So this one would be considered either a sideway or a regular parabola. But now, one more thing that I just want to find out here. Let me just go back to the instruction one more time. Yeah, this one is hard to tell because it doesn't tell you exactly what kind of parabola that is. It could be a sideway, it could be a regular parabola. So you see the questions like this, you got to be a little bit careful because that we can use either one of those structure to find the value of A. Okay, so let's just use the regular format to find the value of A for this problem. So the regular format, which is consider y equals A times the quantity of x minus h squared plus k. So what we have here, y, which is considered 14, by plugging a number. A, that's what we need to find out. X minus h, so negative 3 minus negative 4, and then the whole quantity square, plus k, which is 6. And then from here, you want to solve for a. So before you solve for a, so obviously you want to get rid of the 6 here. So subtract 6 both sides. So we do have 14 minus 6. We do have 8. So that equals a times the quantity of negative 3 plus 4, which is 1. 1 quantity square, it's 1. So that means solving for a divided by 1, so a equals 8. So that's why the answer is 8. Now, I don't like this type of the way that the problem is being constructed here, because that it doesn't tell you exactly what kind of parabola this one is. But let's just read through the phrase one more time. What's the coefficient of the square expression of the parabola equation? Yeah, again, this one is kind of confusing. It could be either the sideway parabola or it could be like a regular up and down parabola. Okay, so you got to be careful with the selections. So here's another one. Okay, so it doesn't tell you exactly whether that's up and down parabola or the sideway parabola. Okay, so now let's move down to question 30. So which of the following best describe the directrix of the parabola? So the directrix of a parabola is a single line that is the same distance from the parabola as the focus is from the parabola. That's what I showed you earlier before. So that one is just like a bottom base line. So it's like a balanced beam of a parabola. And which of the following best describe a single line that is the same distance from the parabola as the focus from the parabola, directrix? And which of the following are the exact same distance from the parabola, directrix, and focus? And you can see that the rest of this, they don't even make sense. 31. And which of the following best describe the focus of a parabola? So it's a single fixed point that is the same distance from the parabola as the directrix is from the parabola. Okay, so let's go through that one more time, the parabola. So again, so let's say we do have the x-axis, the y-axis. So, like that. So let's say that we do have a normal parabola. Okay, facing upward. So here's the focus. Here's the vertex. And then directrix is just like a dotted line here, showing like a balanced beam, supposed to be straight. Okay, so directrix. So as you can see that here, so it's the same distance. So the distance here, they're exactly the same. And which of the following best describe a single fixed point that is the same distance from the parabola as the directrix is from the parabola? Then that'll be a focus. Okay, so they're pretty much the same kind of questions here. And now 32. Which of the following best describe a parabola? So now, one thing I just want to go through here. So as you can see that the parabola, let me go back to that slide. So the parabola here, so the y-axis, okay, let me use another line. If you guys do remember that, the line of symmetry. So there's a line of symmetry going through the parabola here, which is exactly the same as the y-axis. So anytime that I see the line of symmetry, that means there's like a bunch of dots along the line right here. And all those points here, they're called the locus. The reason why they're called the locus, because that in order to measure the distance from one point to the parabola to the locus, and this one which is the same as the distance from the locus to another point on the parabola. It doesn't matter where you put the locus on the parabola, I mean the line of symmetry, it's always showing that the equidistance. Okay, so along the line right here, so there are infinitely many locus, and then you're showing that the equidistance. Okay, so the selection for this one is showing that the locus of a point equidistance from a given directrix and focus. And which of the following best describe the locus of point equidistance from a given directrix and focus? Obviously, it's a parabola. Again, the last one, so which of the following is equidistance from a given directrix and locus? A locus of points called a parabola. So conic sections, so this one probably for some student might be like brand new stuff to you. And your teacher probably have started doing something like that last year. Some teacher probably skipped that because that in Algebra 2, some teacher is going to cover this. So some teacher are going to be doing things like conic section along with completing square, differentiated, like different kind of shape, figure, parabola, ellipses, hyperbola, circles. And then mainly, by the time you're taking pre-cal, you're going to be seeing that the similar stuff again. Okay, so you're more than welcome to watch the video again. Again, always fast forward, rewind, whatever the one that you're getting struggle. So once you pass through the pre-test, and I do encourage you to try all the assessments for this units. Okay, so, and I'll see you guys next time.